Hey guys, hey guys, welcome to my YouTube channel, and today we are going to be solving some of the DP questions that I will try to solve. I mean, I have already solved these questions a long time ago, but I don't remember really how to solve this. But but I have solved enough of questions that I might be able to remember again. And yes, I'm also going to explain how I'm going to think about these problems without, like, I'm not going to write it down, but I am going to uh, try to explain with while talking. Okay, so I hope you guys are going to enjoy. I hope you guys are going to enjoy this video. Okay, so this is the question that this is the first question that I'm going to solve. Knapsack with duplicate items. Okay, yes, so I've completed Strivers almost. I've not done heaps and I've not done strings, and I don't really know what is the weightage for the interview, and I've really left them. And if somehow they tell me to implement heaps and all of these things, then I'm really cooked, because I really don't have any idea of how to do this heaps questions. So anyway, and I hope you guys can hear me really well. If you cannot hear me, maybe I'll try to increase the volume, but yeah, I think you can. So I'm going to do the revision. There are many questions that I have kept it for revision, so I'm going to do questions from that. And there is really a lot of questions that I didn't get time to revise, but there are questions in bit manipulation. There are really important questions in bit manipulation that I didn't solve. Yeah, so let's not waste our time and try to do this question. So you are given a set of items, each with a weight and a value. So this is the value and this is the weight, represented by this. Okay, also a knapsack with a whip capacity. Yeah, right. Your task is to fill the knapsack in such a way that we can get the maximum profit. Yeah, so the maximum profit that we can get. So basically the total number of value is going to be as large as possible, and the number of items, the weights, so the total weights of the item should not go beyond the capacity. This is one constraint, and you need to find the maximum possible value. This is what we need to find. So if we look at the constraint, the weights are 100, so we can do something like value like index is 1000, so index times capacity, weight times capacity, or something like that we can do. So let's try to think about how we can approach this question. So let's say that you are at a particular index. Let's say you are at a particular index, so I, and you are the, basically what's important is what we need to figure out here. So you are at a particular index. I hope that you guys can see me, and whatever I'm writing here, I think it's clearly visible. Okay, so this is the what is represented I. So we are at a particular index, and in a value or weight, whatever, I don't care, and the capacity currently is, let's say it's C. So you are at ith index and capacity is C, and what we really need to find out here is that for a particular capacity C, what is the maximum profit that you can get. So basically what I'm telling is I'm going to define a DP state of 2, which is index comma capacity, because the maximum capacity can be of 1000 and maximum uh, uh, yeah, so 1000 times 1000 it will be 10 to the power 6, which is very uh, which is really, it can be done easily. So yeah, so I'm defining this dp as from the first index to the ith index, what is the maximum profit that you can achieve such that you have a capacity of C. This is what I'm doing. So what is this going to be equal to? This is going to be equal to, either I take that particular value. So if I take that value, so at first let's say that I don't take that value. If I don't take, what it's going to be this, correct? From 1 to I minus 1th index, and capacity still remains the same. And if I take the value, so I can only take the value if the capacity is greater than equals to weight of I, correct? Or maybe y minus 1, because I'm considering that I is starting from 1, correct? If this is the thing, then I'll say dp of I minus 1 comma C minus wt of I minus 1, correct? Or if it is not the case, then I say that, okay, the zero is, I hope you can understand this. So if I am unable to pick, right, if I unable to pick, then I am considering the least possible profit that I can achieve, because if I can do that, if this is the maximum possible thing that I can achieve, then I always do that particular thing. So this is really the thing that I'll do. So now it's time that I hope you guys understood what I did here. So let's try to implement the question. So there are really two state dp. This is really the thing that I'm doing, and I'm going to obviously take the maximum of these values, correct? Alright, so yeah, when I'm at the index I equals to 0, so dp for I equals to 0, I is less than capacity, and that should be equal to capacity, to be honest, I plus plus, and dp of when you are at the 0th index, which means you have just nothing and you have so much capacity, then the maximum profit that you can achieve is just 0, right? This is the base case that we are going to be dealing with. Now let me define this thing. Okay, I plus plus. Okay, so for the first index, what am I going to do? Okay, so if you look at this, the ith state is dependent on the I minus 1 state, correct? So yeah, this is a valid order of doing the things. Now ct and c plus plus. Oh, alright, so dp of I, I'm just going to copy paste this. Alright, so the thing is, if this happens, I'm obviously not just going to do this, but I'm going to add something as well, which is the val of I minus 1, correct? This is what I'll add, not just the things. If I try to take it, so So if I am not able to take it, then there's just 0. If I am able to take it, then I just do this, and I think this is right. And now I just return dp of n of capacity, right? I think they should do. So let's try to, I hope that I'm not really having any edge cases. So let's try to run this. Okay, so this is something I have to take care of. Yeah. Okay, it didn't give the right answer because I have no idea why. What happened here? Oh, alright. I think it might be this thing. I don't know. I'm just assuming things. Yeah, if you are talking about the ayat case, I am going to do this. This should be the correct thing that I'm doing, but I have no idea why it's not really correct. Just take the max. Okay, my output is 2 and I have no idea why it's wrong. The capacity is 3, correct? If the value is this weights values, and I think I'm doing everything correctly. I obviously have to take the current value and add it with, or maybe something wrong here. Wait, yeah, for capacity 0 I think, I think I'm not checking for capacity 0 for all the things which have a capacity of 0. Then it should be 0. For example, if it is like having a 0 capacity, I don't have that particular thing when all of the things have 0 capacity. I'm not handling that case. But it shouldn't be a lot of problem. Where is really the culprit that I'm unable to see? It's really an interesting thing that. Okay, so the only thing that we can do right now is do a dry run. So let's see. I have, for all the dp of I is 0, it's 0. So now I'm starting from 1. So 1 of 0 will depend on 0, and if capacity, the weight is 2, capacity is 0, so this is also 0, correct? So it's so going to be 0. It's an interesting thing that it's not happening. However, I was thinking that it will happen. Hmm, this is really a problem. Like, where am I doing the mistake? I am unable to figure it out. I really thought I could do this, but it turns out that I'm unable to do the things are beyond my capacity. Why my output is 2? Why is my output is 2? Let's try to dry run. That's the only thing that I can do. So what I saw is that this is 0, this is 0, this is also 0, and this is also 0, correct? Now we are talking about dp of 1 of 0. So either dp of minus 1, everything is 0, either I can take that, or dp of minus 1 of anything is still 0. So this is also 0. If I talk about dp of 1 of 1, what can it be? So if you have a capacity of 1, and as you can see that the value weight is 2, so this is also, we cannot do anything but to have 0. So dp of 1 of 2. Now the maximum that you can take, the weight of 2, and so value will be 1, correct? And dp of 1 of 3, if you have, again you are just going to have to have 1. Alright, if you talk about dp of 2 of 0, still 0, correct? Or if weight is equals to greater than this thing which I have here, so is c greater than the weight? Well, obviously not, then it's just going to be this again. So I don't think there is any mistake. So still, let's try to solve it. So if we have 1 as 1, so either of the case, okay, wait, is it talking about the maximum profit that you can make, or what? The second element 3 times. Oh, wait, what? Each item and okay, I didn't see this one. So it's important to actually read the question at its fullest. You read the full question, then only try to solve it, because you haven't seen this thing, right? So I'm just doing the dry run but I had to see the question at first. Yeah, okay. So now everything is changed. So this thing that I was talking, it is not this will be I, but I can again take it. Either I don't take it, or I start to take it again from that particular thing and just try to do it until the capacity is gone. So now if I try to do it, it might be possible that, yeah, okay, I hope this works. Yeah, this did work. So yeah, it was quite good question. So okay, I mistakenly did that. Okay, so now let's talk about the next question that I will be solving. Alright, so I'm here. I've solved this. Now let's try to solve the rod cutting problem. Oh shit. Okay, let's try to do the rod cutting problem now. Alright, so what does the rod cutting problem has to say? You're given a rod of length n inches. Write an array of price, where price denotes the value of a piece of length. Alright, so you know the if you have a particular piece, if you have a particular length of the rod, then this price will give the price of that particular rod, length of the rod, right? Your task is to find the determine the maximum value obtained by cutting up the rod and selling the pieces. Okay, yeah, price is first index array, so yeah, that has to be, because if you don't even have a rod, how are you even pricing it, correct? So yeah, that's quite good. So I just note that, read the full question. All right, so what can we actually say about that? So we need to cut a rod in such a way that the the prices of the length of the rod is actually maximum, correct? And the rod is initially n inches, so I can cut the rod in many pieces, that's for sure. I can cut the rod in, yeah. So basically what I want to say is that I can cut the rod either you know, alright, so I can cut the rod in such a way so that in the beginning alright, so what I'm thinking, let's try to see, let's say that the length of the rod is, I've already cut too much rod, and now the length of the rod is I, right? And now I'm defining whatever the maximum price this is going to have from, if I cut it, like, you know, by once or twice, or maybe even if I just don't cut it anyhow. So what I'm trying to say is that this is going to be max of dp of I, either you keep this value, which is price of I minus 1, or dp of I minus 1 plus price of, you know, 0, basically dp of I minus 2 plus price of 1, and it's basically the maximum of these things until I keep the value, which is like, you know, dp of 0 plus price of I minus 1 maybe. Yeah, this is the thing that I am going to do. And in order to like, really this is the thing. So for each I, if you look at the size of the price, it's 10 to the power 3, and for each of the dp that I'm going to find, it is literally going to take order of n, and so it's again going to be n square. So yeah, I think I'm again good to do this. Although if I had a sparse table, I don't think it will like be, because sparse table is for static arrays. So it's not static, it will not be static if I try to use as sparse table here. So yeah, I cannot really do, I have to do two loops. So yeah, let's try to do this. So obviously this I is just going to be at max of 1e3. So let's try to write it down here. 1e3 plus right 90 dp of n, correct. All right, so this is what I'll need to do. So initially, if you have a 0, if you are at the none of the index, so if you have no 0 index, basically 0 rod, then obviously the price that I'll have is 0 because you have no rod, right? And now what you will do is this thing, and this is the thing. So let's say that I have some maximum which is numeric, or maybe int min initially, or maybe not int min, actually it should be 0, right? Now for I j equals to 0, j is less than equals to I j plus plus, or of 0 to I minus 1 is what I'm finding. So yeah, it should be less than I. Yeah, but the thing is, like, when I'm doing this for, like, I is found. I found the previous of these things. Yeah, I think it's quite good. So maximum equals to max of price of okay, so the price of j plus dp of I minus j minus 1. That's what I need, I think. I minus 1 minus j, and j, price of j goes to at most I minus 1, and when j is I minus 1, it's just 0. Yeah, it's quite alright. Maximum. So I don't even, yeah, like in the end just say this thing. and lastly just return dp of n. That's it, and I don't need this. Let's see if this works or not. There is a failure. Why? Expected. Okay, this works. I hope it doesn't give time limit exceeded. Yeah, it didn't give time limit exceeded, so I think so I did the dot critic problem. Let's try to do questions on strings. So yeah, longest common subsequence. So I need to print the longest common subsequence. That's really the hard part, but yeah, I'll try to do it. Alright, so you're given two strings, which is this one, and I think I have done similar questions on maybe AdCoder as well. So yeah, it's quite good. So how many questions do I think I should do from here? Because there are a lot of DP questions and I really want to do all of them, because especially this part is like there are almost 7 questions. No, I think the total question in this part was 7, and I have marked all 7 for revision. That's really something I'm not proud of, but it's like I don't know, like if I'm proud or I'm not proud, because sometimes you should take pride because you didn't let you down by saying that, yeah, by you're not showing off. That's what I want to say, right? So yeah, let's talk about this. So you need to return the longest common subsequences of these strings. Okay, so the longest common subsequence. Great. All right. Okay, so let me define this state as I comma j, because for s1 let's say I'm at the ith index, and for s2 let's say I'm at the jth index, right? And now what I really want to do is, if I see that the values, so if I see that s1 of I minus 1 is equals to s2 of j minus 2, j minus 1, then dp, because if I see that I need to take, then I should, why don't I take it? Because I don't know if later I'll get a chance to take it or not. I'm getting a chance, I should take it, because if I don't take it, it is not going to be something that later I'll be having something to like more to take, right? Because the length is getting shorter, so I'll never have something more to take, clearly. So the greedy actually works here. So I'll be like, okay, just do this plus 1. But if it is not the case, then I'll be like, okay, do this, maximum of this or maximum of j minus 1, whatever the maximum is, just take that. This is what my recursive solution is going to be. And before I try to solve this question, I should really, because it's really very primitive C++. Okay, alright, I don't know if this is required or not, but it is not going to affect the runtime of the program. It is only going to affect the compile time, but not the actual runtime. Okay, so this is the thing that I'll do. So for that I also need what is the length of the strings. I need to know what is the maximum length that it can go. So it can go to 10 to the power 3. So yeah, again I'm fine. Const int n, which is 23 plus 2, and dp of n. Alright, now this is the thing that I'll do. So, but before that, if I am in the end position, if I have no string at all, then it's just going to be 0, right? If I have literally no string, I am at the last index where there are no string. I'm not even in the first string, I'm at the 0th character. That's just nothing. That's the base case basically. So okay, also I think if instead of writing it like this, I think I should write it like this. If I is 0, so dp of I of j, I'm sorry, if it is 0, it's 0, because at one position I'm at the end, at one position I'm not in the end. So what is the maximum common subsequence? It's just 0, right? This is the base case, and I've already covered 0, 0 here, so I don't need to cover it here. So dp of 0 of j is equals to 0. This is really the base case. Now I just need to go on and care for these things. J is less than equals to m, j plus plus. Yeah, so dp of I of j is literally equal to this thing really. So instead of writing it like this, I'm going to use the ternary operators. S1 of I minus j equals to S2 of j minus 1, and I'm going to do this. If it is true, then I'm just going to return this. J minus 1 plus 1, else max of dp of I minus 1 j comma dp of I of j minus 1. And it's really looking very bad, but yeah, I can fix this by making things after question mark, something like this, so that it doesn't look really very bad, yeah. So I think this should work. Alright, so this is the thing. And now, but what I need here is not the number of subsequence, but I need to count I need to find one of the strings, right? So yeah, I'm going to start. So how am I going to do that? Obviously I'm going to start at the end, like I equals to 1 and I equals to 1. So let's say that I have I and j equals to m, and now I'm going to do it until they all reach 1. So 1. If they reach 1, or maybe not 1, maybe until they reach 0, if they reach if any one of them reach just 0, okay, I'm just done. So let's say that I have a string answer. Alright, so if dp of or maybe if s1 of I minus 1 is equals to s2 of j minus 1, then I'm going to push back of I minus 1, and alright, so this is the thing that I'll do. I'm going to push back this and just do this, correct? Else if dp of I minus 1 of j is greater than dp of I j minus 1, then I'm going to do something different. What am I going to do? Because I minus 1 is greater, then I'm going to do this. I'm going to go towards that which is greater. Else j minus minus. Yeah, I think this will work, and in the end I just reverse the answer. Reverse ans dot begin, ans dot end, and return ans. That's thing. I think this should work. I hope this works. Yeah, this passed the test case. I don't know if it's going to pass the bigger test cases or not. It did pass the test case. So yeah, it's great. Let's talk about the longest palindromic subsequence. Alright, so yeah, I think I'm just going to do dp on strings, and then I'm just going to sleep today. That's it. Alright, so longest palindromic subsequence. So given a string as, find the longest palindromic subsequence length in s. The subsequence can be derived from another. Okay, I know this. I know the definition. Okay, alright. Alright, so I need to find the longest palindromic subsequence. So how can we do that? I have no idea. So I need to think about this problem for a while. So how can we actually come up with the longest palindromic subsequence? So okay, let's try to think that I'm going to define a state. Let's say I. So at the ith index, I'm going to define it the longest palindromic subsequence that it has that can occur from the first index to the ith index, right? Okay. So if I define my dp that, then I just need to find dp of n. But is my definition really accurate? What does this depend really on? I mean, it's just random numbers. I mean, whatever the number, I don't really, I cannot really do anything with that. So I need to think about something different. So let's see what we can come up with. One thing we can do is to really let me think about that. Okay, what if I try to find the longest longest subsequence, common subsequence between this string and the reverse of the string? Will it, like, this is a crazy idea, but I don't know. Like, for example, like we have BBBAB, and let's say that the reverse will be BBBB. So now, well, this is common, these two are common, right? These two are common. So what it eventually does is, like, and lastly this and this is common. Okay, so firstly these two are common, this and this is common, this and this is also common. Can we go further? Because no, we cannot, because this thing is just we have already used that thing, we cannot reuse it again. Oh well, if I have done this, and then if you look at this thing, this is equals to this. It's not we cannot really do a longest palindromic subsequence. All right. Yeah, I don't know, but I'm getting this crazy idea doing it like this. So let's say that I have the total length s dot length, I don't know, I'm not proving it, and int m is just equals to n by 2, and you know that the thing is, if the length is 6, let's say, then your length will be 3. So you're only going to check from the middle, right? This is good. But if you have an odd number like 7, you will 7 by 2 is just 3. You're not going to get to choose for the 4, which is quite what I really want. And let's say that I have a string f, which is just s dot sub str, and by what will this be actually? The okay, so the index from which I really want n plus 1 by 2, right? Or maybe n minus 1 or n by 2. That's the index that I, because n minus 1 0 is there, so and I add them up and I really add 1 as well and then get this value, and then I'm just the length. What is the length? Length is just m, right? So just do m. Alright, so and now I'm just going to do the things that we will do. Const int n equals to 1e3 plus 2 90 dp n, and I'm having when there are no common subsequences, dp of I of 0 is equals to 0, and similarly for this thing 0 comma j is equals to 0. Now I have to do this, just forgot. Alright, so dp of I of j is equals to, again the same thing that I'll do, s of I is equals to f of j, then 1 plus dp of I minus 1 and j minus 1, else max of dp of I minus 1 j comma dp of I j minus 1. Alright, and lastly return dp of n comma m. And I have no idea if this is going to work or not, but some things in my mind is just saying that this will work. Oh yeah, I forgot about the second loop. This ordering works because I and j depends only on the previous either I minus 1 or maybe j minus 1. I remains the same but j minus 1, so the ordering really works, the topological order. So yeah, okay, yeah, the thing is it should be 2 times, but here it will make a really significant difference. What d and b, it should have been 1, right? Shouldn't be 2. I don't know what happened. Yeah, so okay, so it should be actually s dot length by 2, and this will be also s dot length by 2, as you know, that's what maximum it can go. If it is 7, then I'll want it to not go beyond 7, obviously. So maybe I should do this instead. Yeah, that's great. Still not what I expect. All right, so n will get this 3 halves, and this will only get this. All right, yeah, I think I got what is wrong with this approach. Palindromic subsequence. Unable to really find a palindrome. All right, maybe if we don't do it like this, we have another way to do it. All right, let me say this. Let's say I comma j, right? So from, let's say that this definition, this represents the longest palindromic subsequence from the ith index to jth index, right? And what does this depend on? If I and j are equal, then if I and j are equal, then there is almost certain that it will depend on, I have to take it, right? Because if I don't take it, it's not, the length is becoming smaller, and I'm obviously not going to take. If I try to take later, I'm not going to have something more, so I need to take it as greedily as possible. Okay, so I'll be taking only if s of I minus 1 is equals to s of j minus 1, correct? If this is the thing, then I just say that, yeah. Else I just say take the max of dp of I minus 1 j comma dp of I, sorry, this will be plus I and j minus 1. So if you look at this, the topological order is the length becoming smaller from 0 to length becoming eventually to, at max, I don't know what max can go, like n, right? So that's what we need to take care of. So if the length is 0, or the length cannot be 0, but length can be 1, so we are going to do it from equals to 1, and len is less than equals to and len plus plus. All right, and is just equals to s dot length. All right, so how can we actually do this thing? So we have tried the thing before, that it didn't actually like whatever we wanted, whatever we did, it was wrong. Like I couldn't, it might be right, but I couldn't think. So I tried a different approach, right? And I think this should work now because it's really very clean. So yeah, for length 1, length n, I'm obviously, let's say I'm going to take I is 0 to I is less than, obviously I is less than equals to, you know, at max how much I can actually go, n minus len, correct? Because if I add len, then it will be where j ends up, so it's good. Now I know what where j will be, I plus len, correct? Alright, so you have I and you have j, and now what you're going to do is, okay, I didn't consider the base cases, correct? What are the base cases? Okay, maybe I'll consider the base cases later. Okay, I think this will be I plus len, because len is starting from 1, so I am at a particular I and I am adding it and I am subtracting it, so this will really be something like, you know, if I is n minus len, then j becomes, j goes to n minus 1, right? Is that really what I want? No. So I increase it by 1. Alright, so this is the thing. If now if n is this, then it becomes, you know, n. So j is n. So now what I'll do, before I do anything, I should make this thing clear, so that I always start from 1, is that what's the base case? Base case is always going to be dp of 0 of 0, which is 0. It's just you can do nothing, there are nothing common because there are no thing really, or maybe we can maybe do this, maybe start from length 2, right? And for all the length 1, 0 to maybe whatever, I of I is equals to 1, right? This is the base case, so I'm going to start from, you know, length 1. Now also what I'll do is, if I is equals to 0, it's not really 1, right? So it's something wrong, and dp of 0 is just 0. That's what. And also, like, if something is 0 and the other things are maybe palindrome, or I don't know about this one. although I think it's done. This is enough, because it will be length 2 and I minus 1. It will never be I minus 1, it will be I plus 1 always. So yeah, I just copy paste this thing. Right, so if they are equal, then I just say this thing. One thing that I think I forgot to do is that if they are equal, then I think I should instead do plus 2, right? Because they are equal, and if they are equal, then I should add it by 2. I think this is alright. So I need to return dp of 1 to n. That's it. Let's see if this works or not. Yeah, it did work. Okay, so it's really very fast. Right, so last was also very fast. I don't know why people are stuck here. In the both of them, I think this one I did it recursively. Yeah, this is way better, not recursive way of doing the things. Alright, I did this. Now let's try to do this question. Alright, so minimum insertion to make a string palindrome. Given a string S, in one step you can insert any character at any index of the string. Return the minimum number of steps to make S palindrome. Right. Alright, so in one step I can insert any character at any index of the string. Return the minimum number of steps to make S palindrome. Alright, so we need a little bit of thinking here, right? I need to find the minimum number of steps to make a string palindrome. I can only insert, right? I cannot delete. So obviously the first thing that you can always insert the whole string, reverse the string and then insert it at the back, then you will always going to get a palindrome, but it's not the minimum that you are going to take, correct? So if you are at the first position and the last position and you see that they are really equal, then obviously you will not insert anything. You just go and check if these are palindrome or not, and if these are not palindrome, yeah, so I'm talking about, so let's say we are trying to, so okay, directly let's start with this. This is what I'm going to represent, dp of I and j, and I hope this is, I can do n square. Oh yeah, pretty easily. I think this will be the best thing ever. Alright, so yeah, so let me define this dp of I comma j to be something like, let's say from ith to jth index, what is the minimum number of insertion that I can make? So what does this depend on? Well, obviously if again s of I is really equals to s of j minus 1, right? Those strings are really equal. Then I say just don't do anything, no need to insert anything, just check this one, right? But if they are not equal, then do this. So when I'm doing this, I'm actually inserting s of I plus 1 at the right side, so that they become equal. Now I only need to s of I minus 1 at the right side, correct? That's what I'm doing. So that I now only need to care about the remaining portion and see if they are equal, and similarly for this one. And when I do this, I just add 1 to this thing, 1 plus this. That's it, as easy as it can be. Const int n, which will be 502 anti dp of n, right? And again I'm just going to do the same thing for until n equals to 1, len is less than equals to n, len plus plus, and I did not define n, so let me define n as dot length. Alright, I is less than or equals to len n minus len plus 1 I plus plus, and j, this is going to start from 1, 90j will be I plus len minus 1, correct? J will be this, when I will be n minus len plus 1, j is just going to be n, right? That's it, that's what I need. Alright, now I just need to copy paste this one. I didn't put a question mark here though. And I didn't also consider what will be the base case. I know what to return. I need to return dp of n, 1 to n. Okay, so what will be the base case? Base case will be when everything is in length, for length 1, for all of the length 1, maybe I should do something like this. Yeah, I just don't need to insert anything, correct? This is the base case. Alright, so I think this is done and dusted. I hope so. Yeah. I don't know why is this labeled hard. It's quite easy. Initially I did all of these using recursive solution, which was really big, and it was like I had a fear to write the recursion because of how big it was. Okay, let's try to do this. Shortest common subsequence. How many questions are there? Only 3, and then I'll just sleep. I don't know, like, watching Game of Thrones was really very fun than doing these things. I could really watch Game of Thrones for like without getting tired. But now I'm just counting each and every question. It feels like an hour, but it's really just 1 o'clock. I used to really watch like till 5 o'clock the Game of Thrones until it finished. Like, but I cannot do DSA questions, and I have an intern, but I still cannot. Anyways, I also need to revise my projects. Okay, no problem. Given two string, return the shortest string that has both s1 string 1 and string 2 as subsequences. Wait, what? Oh, alright. It is almost like LCM, lowest common multiple. In Bengali, it is also called Lashagu. Alright, so I just need to return the largest string. Okay, so if I remember the, you know, if I have, let's say, two numbers A and B, and I need to find the GCD of, LCM of these two things. It's really, if you look at the thing, what you do is, whatever the common factors you have, the maximum, the greatest common divisor that you have of both, is you take that, and when you do A times B, you multiply the greatest common divisor 2 times. So you just do this. So what I am saying is that the greatest common divisor multiplied the other factors that were left for B and for A. That's what you are going to do. So whatever there is left, so basically, if you, let's say, you have this represents the whatever is left for B, this represents whatever is left in A, and obviously this thing and this thing has nothing in common. If there was some factor common between this, then the GCD of A and B is also going to take, that's never going to happen, because if they have something in common, then A and B, the GCD you have not calculated to really well. That's right. So, and then in the end, I am just going to multiply it by A, B, C. So really, what you need to find out is GCD, right? The common thing that you have. So in this string 1 and string 2, I just need to find out what is the maximum common subsequence that I can find, right? Once I get it, the minimum string that you need to insert is basically, or maybe something else. Let me think about this question. Yeah, if I take whatever the longest common subsequence these two have, I take that, and I add the length of these two, obviously, and then obviously the longest common sequence that I have, I'm going to subtract it once because I've added it 2 times. This is what I'm thinking the solution will be, but it might not be the case. I am thinking of some counter example that, or maybe trying to prove this will actually be true. Let me think about this for a while. Okay, so what my suggestion is, like to find the LCM a comma b. What you do is a times b divided by GCD of a comma b, right? And in order to find the answer for string 1 and string 2, this will be len1, length of the first string, length of the second string, minus the longest common subsequence of string 1 and string 2. This is the thing. It's similar to this. It's almost like log of LCM. If you take log on both sides, it will be converted to addition, right? And these are all, many perspective, and it's almost similar if you look at this thing. So I think you got what I am trying to say. This is really what I'm trying to say. I can find the LCS really easily, but is it really the true? That is what I'm thinking right now. So I want you to give me 10 minutes or maybe 5 minutes to think about this problem. Yeah, I think it's going to work fine. So just try to do this. And instead of str1, I really don't like this naming. Too big name. Okay. So s1 dot length and m equals to s2 dot length. And yeah, I'm going to find the LCS. So to find the LCS, I think what I used was TP of I and j, so 0 plus plus and j is less than equals to j plus plus, and s1 of I minus 1 is equals to dp of I of j is just equals to, so s1 of I minus 1 is equals to s2 of j minus 1. Then one plus dp of I minus 1 j minus 1 else max of dp of I minus 1 j comma dp of I of j minus 1, right? And I think I'm done with this thing. I just need to take care of the base case. dp of I of 0 equals 0. dp of, yeah, this is just, yeah, equals to 0. Yeah, and now here, because this is 1000, so again const int n equals to 183 plus 2 dp of n comma n, right? And what I'm going to return, n plus m minus dp of 1 to n of m, right? I hope this works. Oh, I need to return the string, shit. Alright, I forgot this one. Okay, this is really not what I wanted. So how can I return the string? To return the string, I again need to find out. So there have to be something, and I should do something to find out the string. Actually, you will have s1 and you will have s2. I did not see that I need to return the string, and I thought I just need to do return the. Okay, so after you find the LCS, you will know what is the string. And once you get the string, if you see that okay, alright, so I think I need to do something similar. Int n I equals to n, j equals to m, and while this is truth, okay, so if I say that I of j is equals to s2 of j minus 1, and I also need to return a string answer equals to this. So if I see that they are equal, then I'm also going to push back s of I minus 1, right? And I minus 1 j minus minus, else if dp of I plus 1, I minus 1 of j greater than dp of I of j minus 1, this is greater, I'm going to switch to that. Answer dot push s1 of I minus 1, correct, I minus else answer dot push. Obviously this will be back s2 of j minus 1, so minus, and then I'm just going to reverse and return hands. I think this should work now. I don't know if this will work or not, but I am hoping that this work. Okay, it didn't work. All right. So AB is the longest common subsequence. Oh yeah, I forgot to do this one. While I is greater than 0, or maybe j is greater than 0, whatever is greater than 0, answer dot push back s1 of I minus 1, I minus. It's almost like merge sort. Answer dot push back s2 of j minus 1, j minus. I don't really know if this is, I literally have no idea if this, like, why is this working. Oh my god, but how I did the last time, I did it recursively. I think. Oh, I didn't. Oh, I literally did. Quite good. I did in the same way as I did here. Yeah, okay, nice. Only two are left. Okay. Alright, I think I'll not really say a word, just solve this, because it's almost the same thing, I think, yeah, as this. I've solved this one and it's almost the same, so I'll not really try to do this too much. Okay, so just say const int n, which is equals to 502 and tp of n comma n, and yeah, edit distance. What is this? Okay, so I need to convert word 1 to word 2. Either I can delete things in word 1, either I can delete things in word 1, I can add things in word 1, and I can do whatever the hell I want. Okay, I'm really thinking of how to do this. 500 times 500, and it will give me maybe 3D dB or maybe 1D dB. I have to do any one of the things. Like, I'm trying to think of a 4D dB solution, but 4D dB is just going to be too much. It's already 5 to the power 4 and 100 times 4, which is almost 10 to the power 6, which is already what I'm doing. Alright, okay. Maybe I can do it in n square. Okay, I think I can do it in n square. Maybe, maybe not. I have no idea. So let me define dp of I of j, and let me I don't want, I just want this. Yes, so what this is going to represent is basically from 1 to ith index of s1 and 1 to jth index of s2. How can I convert basically what is the minimum number of operations that I'll take to convert s1 dot sub str of 0 to I plus 1 to s2 to sub str 0 of j plus 1. Like what is the minimum number of operations that I need to convert this to this is what my dp is going to represent. Or if whatever the thing is. Yeah, I think it's j. This is much better. Yeah, so this is what I'll represent, and the final answer is just very easy. It's just dp of n comma m, and n comma m is just the respective length of s1 and s2. So what will this depend on? So if I think that s1 of I minus 1 is equals to s2 of j minus 1, then I just don't need to do anything. Just do this. Correct? But if it's not what I want, then I can do two of the things. Either I can delete what I have currently, but later I'll need to insert it, so I won't do it. Or I can really insert something right in the end. So if I insert it, I'm just so it can be two of the things. Insertion, it is going to be dp of, if I insert, then it just remains same, but this happens, and So I remain same, but the j becomes -1 because I've inserted that. But deletion, if I do try to delete it, then what happens if I deleted that? I need to see if I -1 and j is the thing or not. Whatever this is, these are the three things possible. So when it's really done, we just need to take care of the base case, and if you look at it, it's always dependent on the previous i's or j's. So normally how you used to do, this time also we are just going to do the same thing. dp of I of j. Okay, so if s1 of I minus 1 is equals to s2 of j minus 1, then dp of I of j is equals to, I just don't need to do anything, j minus 1, else why am I even doing this? I just need to take the minimum of this, correct? It's the same thing again over. So let's not do this and apply ternary operator. Question mark. If this is not the case, you just need to take care of the base case, that's it. It will be 1 plus minimum of dp of I of j plus 1 dp of I minus 1 of j. Yeah, that's what you need. It's almost the same thing. Yeah, so this is s1 dot length, and this is this, and what will be the base case? That's what you need to take care of. Well, the base case, yeah. dp of I of 0 is equals to I. This is j is less than equals to m, j plus plus, and I'm done with dp of 0 of j equals to, I'm done with j already, j. Alright, I think that's enough. Return dp of n comma m. Yeah, I think this will work. Okay, it didn't work. Why didn't it work? What? Word 1 to word 2. What is wrong with this thing? What the heck? Why didn't it work? It should work when they are equal. Oh, okay. maybe I plus 1 and j plus 1 also. Let me see if where am I making a mistake. Okay, so I have R and I have S. I delete these 3 and add an O. That's what I said. But here it is telling me, oh, I can also replace. Oh my god, I forgot about the replace one. Yeah, if I replace, it changes everything. I can just directly replace or maybe add, maybe some. Okay, so let me replace this then. I minus 1 and j minus 1. Yeah, I think this will do. I forgot to take this one. Yeah, okay. And it was really quite easy. I hope it's not giving wrong answer to me. Yeah, okay. Okay, the last question that I'll do for today, and I'll tell you goodbye. Oh my god, I think okay, I don't know, I forgot what I was thinking. So let's try to do this. You have given a string as a pattern P, this and this. Implement a wildcard pattern matching with support for this and this. Where this matches any single character and this matches. Okay, what is it even talking about? Okay, given as input string as and a pattern P, implement the wildcard pattern matching with support for this. So question mark matches any single character and star mark matches any sequence of characters. So for example, so if there are star mark, then I can put any thing over there, correct? Is that what it's trying to say? And if there is a question mark, I can just add only one of the things. Alright, so I just need to check if it is possible to do or not. Alright, I just need to check if it is possible to do or not. So how can I do this particular thing? If I ever encounter a star mark, if I ever encounter a star mark, then I can just skip as many as I want, right? So let's talk about that I am at position I. And what is the, okay, it's 2000. I can really do, I don't know, man. I need to think about this question. Okay, so what can we really do here? Can we really do something? Like for example, here I can just put A and I'm done. I can only put one character C, but second letter is A. Here we can do nothing about it. Alright. Okay, so I'm here, right? This will tell me if I am at string S at a particular index I of string S and a particular index and the jth index of P, then tell me if from 1 to ith index of S, is that possible to make with whatever I have here at from 1 to jth index of P? Is it possible to make? That is what I am trying to do with dp of I of j. And how can we know this thing? If S of I, let's say is equals to P of j minus 1, then what can we say? Then just say whatever is there, correct? But if it's not equal, then what? Then I need to check if P of j is equals to question mark. If it is question mark, then if it is okay, if it is question mark, then is it necessary for me to put something, or is it not? Then also I just do this, correct? But if it is not question mark, it's something else, which is this star mark, then I need to go to that particular thing where else if P of j minus 1 is not equals to this thing, correct? Then I just return false, right? But if this is also not true, then I need to go to that position. I need to go to that position where I will not find a star mark there, I think. Okay, so I'm still left with m minus I plus 1. Things are still left. Sorry, j. Things are still left because I'm at here, or maybe just m minus j. Things are still left. So I is just going to be, n minus m minus j. If this is only equals to greater than I, then only I'll do this. Or maybe I think I'm doing something wrong here. I'm going to the right direction. I mean, not the. I'm going from left to right. I'm not actually going the right direction. Not the right one. Okay, so what I'll do is basically star is there, and there will be a lot of stars. Okay, now this is actually making it really difficult. If there are star marks, then alright. So this is actually very difficult. The only problem is when there is a star mark. I have no idea what to do now when it's going to have a star mark. I'm already doing n square, but if I take a loop here, then it's just over. So I need to come up with something different. And what should I come up with? That is what I need to think. If P of I of j is star mark, okay, then what can I do? Is there any P of j minus this star mark? I'm at this index and I'm at here, and this is star mark, and I don't know what to do. I really don't know how to do this now. if I'm at a particular position, I just need to find out if I'm at a particular position I am j, right? And I want to find out if from 1 to ith index of s, jth index of x, is it possible that I can make this the s string from this p string? Is it possible to make or not? That's what I need to find out. So how can I do this? Okay, I think if dp of I of j minus 1 is true, or like if this is true then it's okay, if this is false then what to do? Like there was no way we can make it true. This is already false and I'm taking it, I'm here right now, then it's obvious that I'll have nothing to do. Or maybe it was false only because the length was lesser. So yeah, if this is the thing, then true, right? But if it is not the thing, then I have to check if this was true, then this is also true. Okay, so one more thing we need to do. If okay, empty sequence is also possible, right? Nice, this is perfect. You can also make empty sequences as well. So let me think. If I is less than something that I need to think of, and what is really that? this is the thing that's wrong. Alright, I don't have any problem. But if this is false, then what to do? That's what I'm thinking. This is false. Okay, I'm thinking if I minus j minus I, if only if this is positive, then I minus j minus I, sorry, I think it will be I minus j, I think, correct. Because it could also be empty sequences, and yeah, empty sequences is what we need to take care of. But if it's not true, then what do we need to think? So I think, yeah, I think I know what to do. J minus I is plus 1. Alright, so I'm going to subtract I. I have j minus I, so j is greater of what I'm thinking. J should be smaller, so I minus j, it should be right. So instead of doing all of these things, I should just directly say if dp of yeah, if only if j is less than I, then I can say j of or maybe j or maybe it's true or not, or maybe this won't be true. But if this is true, this will also be true, this is also be true, this is also true. Okay, I think I'm just thinking too much. It's just going to be this or dp of I minus 1j. That's it. If this is, all of them are false, then just false, and I cannot do anything else. If it's a question mark, then just check for the back. if it's true or not. If it's not a star, then false. Correct. Alright, I think this is quite right of what I could think of. So let's try to implement this. So yeah, for as you can see, everything depends on the previous one. So yeah, and I equals to 1, I is less than equals to n I plus plus. For int j equals to 1, j is less than equals to mj plus plus. So if s of I minus 1 is equals to p of j minus 1, then dp of I of j is just going to be dp of I minus 1 j minus 1. But else if p of j minus 1 is equals to question mark, then dp of I of j is equals to dp of I minus 1 and j minus 1. So instead of writing like this, I can just directly write it here by putting an r. Correct? If this is not case, then this or this, they both are false, and is not equals to star, then dp of I of j is equals to false. Else dp of I of j minus 1 dp of I of j equals to dp of I of j minus 1 or dp of I minus 1 of j. I think this will do. Yeah, I think there's nothing more to cover. Alright, now talking about the base case. So what is going to be the base case? Right, so when you are empty, when this string can be empty as well. Yeah, so when this string is this is empty and this is also empty, then I just say it's true. dp of 0, 0 is 1, and if it has something, this is still 0, then it's false. dp of I of 0 equals to 0. But if this string is 0 and there is something here, correct, Now that I know this, I don't think I need to know anything more. Still dp of 0 of j. What is this going to be? So if there is something here and nothing here, then okay, first I will like dp of can question mark matches in single character. Okay, single character, but if j is something j can be many things. Yeah, okay, I think I got this. dp of 0 of j minus 1, or if that's true and that p of j is equals to this, if that is true and this is this, then I'm done. If these both are true, then only I can just say this. But if this is true and this is false, then it's something else. But something else will never match an empty sequence, so yeah, it will be false. So now it's time 2e3 plus 2 into dp and right. Lastly, I just need to return what was the answer that I need to return. dp of n comma m, correct? What happened here? Oh, okay, this would be boolean. It did work. I don't know if it will actually work for all of them or not. Okay, it did work. There is also a very good solution as well. I don't know what I did back. Yeah, the recursion. Of course, the recursion. Yeah, and this time I did really better, in a better way. Okay guys, that's it for today.